11.2b homework. So 5 and 1/2 plus 2 and 1/9. First, I'm going to convert these mixed numbers, and they're called mixed numbers because they have the whole number and they have a fraction, into improper fractions. So I'm going to say 5 times 2 plus 1. So 5, which is the whole number, times the denominator 2 plus the numerator 1. Okay, so 5 times 2 is 10, 10 plus 1 is 11, and then we stick it back over the old denominator. Next, I'm going to convert the other one. 2 times 9 plus 1. So it's going to be 2 times 9 plus 1. 2 times 9 is 18. 18 plus 1 is 19. Put 19 over the old denominator, which was 9. So you have 11 halves plus 19 ninths. So again, 11 halves plus 19 ninths. Next, I want to find the least common denominator of a 2 and a 9. So multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18. Multiples of 9 are 9, 18. First one that matches is the 18. That's the least common multiple, or least common denominator in this case. So we want to turn both of these denominators into 18. So to get the 2 to turn into an 18, I have to multiply it by 9, which means that to keep the equivalent fraction, I have to multiply the numerator by 9. And that gives 99 eighteenths. Plus, to convert this 9 to turn it into an 18, I have to multiply it by 2. To keep an equivalent fraction, I have to multiply the numerator by 2 as well. 19 times 2 is 38. And we put 9 times 2 is 18. Then the numerator is 99 plus 38 all over 18. So 99 plus 38 is 137 over 18. Now at this point, if we can reduce this, we would reduce this. And there's nothing I can divide into both a 137 and an 18. Now if you want to, you could leave it as an improper fraction. If it asks you to put it as a proper a mixed number, what you would do is you would say 137 divided by 18, and you'd say, oh, well, how many times does 18 go into 137? So 18 goes into 137 7 times. 7 times 18, 6. 126. 137 minus 126 is an 11, so we have a remainder of 11. So now we use this to convert it to 7 and 11. It's this 11, it's the remainder, is the new numerator. 11, we put it over the old denominator, which is 18. So if we wanted to turn it back to a mixed number, we'd have 7 11/18. Now simplify by factoring. The radical of square root of 50. So first of all, we're going to see what perfect square we can factor out. And by perfect square, I'm talking about these things on the right side. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, and 5 squared is 25. Now, since I can divide 50 evenly by 25, so if I divide 50 by 25, I get a 2. So the factorization of 50 is 25 times 2. Now, we can break this apart into the square root of 25 times the square root of 2. Square root of 25 is 5, and we leave the square root of 2. So simplification of this is 5 square roots of 2. Another way of doing this is the prime factorization of 50. Prime factorization of 50 would be 2 times 5 times 5. So I could go over here and I could say 50 divided by 2 is 25. 25 divided by 5 is 5, and 5 divided by 5 is 1. And so the prime factorization would be 2 times 5 times 5. Now we're looking for, because the understood or implied index there is a 2, we're going to pull 2 5s out and write it down once. And whatever's left over inside the radical is going to stay there, and you still get 5 square roots of 2. That's another way of doing it. And they both will always work. For the easy numbers, it's probably better to just do the factor out the perfect square. For the more complex numbers, you probably want to do prime factorization instead. Just kind of a rule of thumb. Okay, so what's the largest perfect square that I can factor out of a 90? So we could factor a 9 out, and that leaves me a 10. Again, 3 times 3 is 9. And 9 is the largest one of those perfect squares that I can factor out of a 90. 90 divided by 9 is 10. So we get this 10 over here. Now I'm going to break it apart into the square root of 9 times the square root of 10. Square root of 9 is 3. You end up with 3 square roots of 10. The way of doing this through the prime factorization. So you'd say 2 times 3 times 3 times 5, right? Prime factorization would look something like this. 90 divided by 2 is 45. 45 divided by 3 is 15. Divided by 3 is 5. Divided by 5 is 1. Prime factorization is 2 times 3 times 3 times 5. 2 times 3 times 3 times 5. Now, what can we pull out of here? Well, we have a pair of 3's we can pull out. We can only pull out a pair. And everything else that's left, we leave it underneath the radical sign, so 2 times 5. 3 is on the outside. 2 times 5 is 10. You still end up with 3 square roots of 10. So we have the square root of 63. Two ways of doing this. First, we could factor a 9 out of 63. So we could say 9. 63 divided by 9 is 7. So 9 times 7. Square root of 9 is, or square root of 9 times square root of 7. Square root of 9 is 3. So you end up with 3 square roots of 7. Other way we can do this is through prime factorization. 63 divided by 3 is 21. 21 divided by 3 is 7. And 7 divided by 7 is 1. So prime factorization is 3 times 3 times 7. So you end up with 3 times 3 times 7. Since you have a pair of 3's here, you pull it out. On the outside, you write a 3. And whatever's left over, which is the 7 in this case, you write on the inside. And you have it. So simplify by factoring, square root of 28. So the square root of 28, we can break that apart. What can we, largest perfect square that I can factor out, it can either be a 1, 4, 9, 25, and so on and so forth, right? So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, so on and so forth. So the largest thing I can factor out of here is a 4, and that leaves me a 7, which means I just take the square root of the 4, square root of 7, square root of 4 is 2, 2 square roots of 7. Another way of doing this is prime factorization. Let's do prime factorization first. Of 28. 28 divided by 2 is 14. Divided by 2 is 7. Divided by 7 is 1. When you get the 1, you know you're done. So that gives me 2 times 2 times 7. Now we want to pull out a pair. Pull out the 2. And we leave the 7 underneath, so we get 2 square roots of 7. Next we have a 112. You can try to pull out the perfect square root of a 112, and you might be able to do it, but as the numbers get larger, usually it's a better idea just to do the prime factorization, right? So 112 divided by 2 is 56, divided by 2 is 28, divided by 2 is 14, divided by 2 is 7, divided by 7 is 1. And what that does is that leaves you 2 times 2 times 2 times 2 times 7. Now, we want to pull out sets of 2. We have 2's there, and we have 2's there. And we pull it out, and whatever's on the outside gets multiplied together, and whatever's on the inside gets multiplied together. So 2 times 2 is 4, and we keep the 7 on the inside. Now, if we were to pull out the perfect square of this, we would probably want to pull out a 16. And that would be a 7. So square root of 16 times square root of 7, square root of 16 is 4. You end up with 4 square roots of 7.